at the bottom it says the power of one right there? So that power of one, it goes back to businesses. And I'll kind of tell you a little quick story about how that works is 1 degree can affect the sales of different businesses so much. So I want to get into that a little bit more, and I want to talk about how an expert in that field knows that and sharing that information with our own Fox Weather. We got, look at this, Captain Kirk, the real Captain Kirk in the house this morning.
There you go, Drew, right? If you're going to be Captain Kirk, you better have a spaceship, right?
I love that. This is so cool. So the real Captain Kirk, he is in the Lehigh Valley. Your company is Weather Trends 360. And what's really cool about what you do is you guys forecast pretty far out in time, don't you?
A year out, yep. And we don't change our minds. So I know that's crazy physics, right? We got to change your forecast, but we don't.
So to that point, so think about that. He for his clients, and now even for Fox Weather. So if you get the Fox Weather app and go to the event tab on the app, you can get forecasts for like, what is it going to be on Thanksgiving? And you guys are using kind of similar ideas for how we do long-term forecast for winter forecast, but you're getting more precise. You're really kind of getting into the details. How detailed do you get for a year out, and how's it do in terms of the accuracy?
Yeah, so as you and I are physicists, right? Physics, meteorology, fluid dynamics, right? The degree. You have to think differently because that works great for a week or two. But if you're going to do year ahead, and I said year ahead, by week, everywhere on Earth, 32 million spots. So we predict the sensible metrics, temperatures, growing degree day, cooling degree day, high-low temps, rain by week, snowfall by week, again, every mile on Earth. Again, with a process that doesn't change. So what you got to do is you got to look at all the statistics and data for today, look at dozens of climate cycles. It's not just La Nina. You got to look at a lot more than just La Nina, right? I mean, the hurricane season is a classic example. Everyone kind of overlooks an MJO cycle that crushed the hurricane season up until, yesterday?
Hey, could I jump in on that just to break that down a little bit? So when you talk about La Nina, El Nino, that's just talking how warmer than average water off the coast of South America affects where our jet stream is, and that's the storm track, and it's also the barrier between cold and warm air, so it shifts where it's cold, where it's warm. The other one that you just mentioned, can you educate me a little bit more about that one, how that's been doing well for this hurricane season?
Yeah, so the MJO, what Maddie and Julian oscillation cycle, is just a tropical pulse of convective activity. So anytime you have a massive area of convection, say in the Indian Ocean, you're going to have a downstream somewhere else, maybe over us in the Atlantic, of sinking air, which sinking means you dry out, right? So we had that pulse over here, maybe in the Indian Ocean, but it created a very negative influence on the Atlantic basin. But after Ernesto, right? So from mid-August to just a week ago, right? Everyone thought the hurricane season was dead. It was the least active in 55 years for that 3-week stretch. And then it exploded here, right? We've got probably 4 or 5 systems that NOAA's watching out there. So that pulse is, again, becoming a more favorable. It's shifting. And as it shifts, then so does the dry air, sinking air over the Atlantic is shifting, right? So now a much more favorable environment in the peak of the hurricane season. So again, everyone got lulled to sleep thinking the season was over maybe a week ago, and now all of a sudden it's like, wait a minute, it's coming to life. Because of this one, it's one of many cycles that we have to factor. Again, we look at it differently, though. We're looking at it for a year from now.
And one of the things you said that really resonated with me, what goes up is going to come down. And that's kind of exactly what you're talking about. When you talk about the convection, it gets the storm row, gets the moisture up in the air, and then at some point that air is coming down, that's drier weather, that's stopping air from rising, and we get clouds and rain, and, ultimately big hurricanes, area clouds and rain from when air is rising. But if air is coming down, it's stopping it. We're not getting it. And to your point, I was talking to my colleague Kathy Orr yesterday, and she brought up a really good point. So we got this huge area of high pressure keeping our weather really nice here at home. Well, the moisture that's left over from this guy right here, as that fizzles out, it kind of just fizzles out and it leaves all the moisture around us. And then eventually we end up getting it next week. So even though it's not giving us a direct impact to drop some of the rain, we're going to end up getting some of that moisture from it next week. In fact, starting Tuesday of next week, it's actually pretty cloudy and it stays cloudy right through the end of the week. And it goes back to your point. What goes up goes down. And that's some of the stuff that you guys study is just kind of how the Earth is this big system, that something right here can affect something right there. And that's how you put together this year forecast. I love that.
The joke was the butterfly effect, right? A butterfly flaps its wings and it changes the weather, right? We're not that sophisticated, but I mean, again, something that happens here will definitely have an influence over here, right? So if you can understand all of those interactions and statistics and the cycles that go into that, again, Clark, that was the first 11 days in the Northeast, right? Last year was the hottest in history, this first 11 days. It was record hot. It was 89, 90 degrees. And then this year it's the coldest in 30 years. We had, don't know how many nights we had in the 40s here, up in Lehigh Valley, at least the low to mid 40s, right? I mean, night after night. So again, coldest in 30, about an 18-degree change. That power one, 18 degrees change. I'm wearing a jacket. It gets freezing, not today, but, it's been cold, right? So the kids were in school, like, it's cold. I got to give them a jacket, right? You weren't even thinking about that last year, right? So that huge change in the weather had a huge change in seasonal sales purchases because you're a human, right? You're suffering from it just like all the rest of us.
Oh, yeah. Let's dig down a little bit more into this. So I'm pulling up a little sample of this Power One. This is something you'll share with your clients. And by the way, just to kind of get everyone on the same page. So I got to say thank you so much. Bill's been kind enough to come into my classes that I teach over the years, and he's been so generous with his time. So I know a little bit of what kind of he does, and I just think it's so interesting with his clients. He's got big-time clients. We're talking big box stores and big brand names that you've heard all the time, and they're using some of his information to help make better business decisions, to help figure out, all right, what should we market then? And so here's a little sample of one of the things that you kind of share with clients. And what this is saying, and correct me if I'm wrong, it's saying, hey, this is kind of a little colder than average, and then notice how, because we're that much colder than average, even just 1 degree colder than average, look how it affects sales of this and that.
Yeah, so again, our clients would actually get something more like taking this power of one, but applying it. We analyze their point of sale data, what you bought in a store over the last 3, 4, 5, 10 years, correlate that, model it. Now we do that in 30 seconds, and then project their sales by week, by store, every mile on earth, anywhere they have a store. Again, Coca-Cola, one big client. Again, they do it in all 195 countries, right? Predicting Coke volume everywhere on earth. So again, this is Christmas week. We have it the coldest in 7 years nationally. That's a national average. 11 degrees colder than last year. You apply. Now, you got to be careful because the power of one applies by store. So what's cold in Miami is different than what's cold in Philadelphia.
Well said.
Right? So again, we understand those nuances of the consumer, right? So you get the 60 in Miami, right? They're freezing, right? So
think about that. You start getting the lizards or something starts falling out of the trees when it gets too
38
cold.
degrees. They kind of like go to sleep, fall asleep. They don't die, but at least they go, yeah, we're hibernating. So power this one, again, things like the most volatile analysis we've ever done. We've analyzed 10,000 seasonal categories. The one that was the most volatile was electric bedding, right? You either need an electric blanket or you don't. So every degree colder around December, there's a 24% bounce in sales. So that 11 times 24 is, it's triple-digit sales gains for these categories. So again, understanding that, very important, right? I need more inventory this winter. You definitely, remember 2 winters ago, December was epic cold of all time, right? I mean, it's historic cold. New York City, I think the second coldest in hundreds of years. And then last year, one of the hottest in history. And now this year is probably not as good as 2 years ago, but it's a good December, we believe.
Yeah, and to that point, so here's why I pulled up, Captain Kirk. So right off your website, you have something like this. And would this be something that you would send out to different clients to kind of give them, when it's colder or warmer than average, and then how that historically has affected sales in their sectors?
Right. So we explain the weather, right? We tell the client both what the weather's going to do week by week, year out, month by month, and their sales. The bottom part of this chart is their sales forecast. So this might be heaters, so a week is really red. It's down, 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 down. You've got to do a price incentive, right? Convince a consumer to, like right now, if you're trying to, last week, you could have sold a coat, no problem, right? A jacket, light jacket, people probably got one if they needed it for their kids. This week, if it's going to be in the 80s, forget about it. I'm not going to go do it this week. I'm just not going to do it, right? So you got to convince me. Now, if you tell me you got a 30% off markdown price promotion, yeah, I might go get it. If I know about it, I hear it. So we always say price works when the weather's against you. And when the weather's working last week, you didn't need to give me a price incentive. I was going to go get it no matter what. I'm freezing. My kid's standing in line at school, right? So that's how you can kind of test your inventory, your advertising, marketing, really it's every phase of a retail supplier's business.
And at the end of the day, like you said, it's power 1 degree. All right, so here's what I want to do. After the break, we're going to take a quick 2-minute break. I want to talk about some of the stuff you're doing for Fox Weather, how we can get some of your forecasts. Like, if I got something going on, I want to see what the forecast is going to be if there's a wedding or something. So I want to talk more about that, and I want to talk a little bit more about some of those impacts of those business. We'll do that in 2 minutes. We'll see you right back here in 2. So good to have you back right here at the FOX29 Weather Authority Weather Center. I was joking to the real Captain Bill Kirk. He's in the command center there in the Lehigh Valley for Weather Trends 360. We're in both our command centers today, right?
It's a little chilly in here.
I can tell that. So I love that. I love that Captain Kirk, and you run with that. And that is your actual name, right? Just like the Star Trek guy.
Yeah, I mean, I was a Gulf War veteran. I'm dating myself, 1989, General Storm and Norman Schwarzkopf. That's kind of where our technology started in theory. It was like, you're a scientist, give me an answer, and don't change your mind. Okay, let's just dump 4 years of Rutgers in physics and think statistics and cycles, right? But it did. It set us on a trajectory of doing what we do today. If we changed our mind, our clients would leave us in droves. But because we create a long-range forecast that doesn't change, they love us.
And to that point, I was just thinking of the military. Think about the D-Day forecast. When it comes to the military, stuff is going, and it's going days in advance, and you can't really stop things once it gets moving. So you need that accurate forecast. And it's so kind of fascinating to me to hear that's how you got started, from your service in the military and them saying, hey, give me the forecast. It's got to be right. We got to get this all set. And then you took that over to businesses. And part of the reason we're talking with you today is you're partnering, that is, with Fox Weather. So the national guys, this is Fox Weather Philly, but the national guys, you can watch Fox Weather on FOX29 on one of our streaming channels online as well. So it's online at fox29.com, click on weather. Or if you got a regular TV over the air, you can find Fox Weather, and it's also on YouTube TV. But anyway, you guys are giving this long-term forecast that you guys do on the Fox Weather app. You go into it, you click events. Tell me what we would find there.
Yeah, so for a couple of years, they made it keep it top secret, right? Nobody knew that we were doing it for the last few years. But so yeah, go to Fox Weather. They used to call it Plan. Now it's Events, right? So it's like the fourth little tab down there. But you can pick any date, your own date, wedding, vacation, anywhere you want to go, holidays, and it'll give you our statistical trend. Now, again, a lot of times those are a day event, Thanksgiving Day. I always say be careful with that. I mean, we will say that, again, Christmas week is the coldest in 7 years, 11 degrees colder than last year, right? So that's a week, right? So any given day, it should be overall a cold theme. So, but again, it's a great app. Again, they've got, I don't know, I think 15 plus million people looking at that thing.
That's cool.
So again, it's pick your date, your time, your event, and that's important to you. You can have 100 of them. They got some clients that are actually looking at, they've got hundreds of locations. Like, okay, this guy's got a lot of things going on. But it'll tell you the weather, So again, how do we do that? If I tell you a given week is the coldest, right, behind the scenes of that app is if I tell you Thanksgiving week is, or Christmas week is the coldest in 7 years, maybe the wettest in 10, which implies it's the snowiest in 9, right? That trend of 9 years, 10 years, cold, that's the strength of our technology. So if I know that, the odds are a period in that week, you're going to have at least rumor or threat of that event, cold, wet, snowy. So again, that's how we kind of take that down to a given day.
It goes back to what you were saying, I mean, that it's in the name of your business, weather trends, because it's a trend. And I really like what you have up on the screen right there. You shared it with us, and we were just chatting about this, that you heard it here first, the coldest Christmas in the Northeast, and you get to kind of see it on that map right there, in about 7 years. So a colder than average Christmas this year, and folks that want a white Christmas, Captain Kirk, I'm telling you, they want to hear that news.
There's hope, right? I got some Wall Street client. We got like 24 big Wall Street banks, and I got some of my Wall Street guys that he's crazy about snow at Christmas. He lives near New York City. I'm like, your odds are about 8% on any given Christmas, right? I mean, so he really wants a white Christmas this year.
So one of the things we were chatting about, and I just thought this is kind of cool, looking at technology, is how AI is going to improve forecast. And from your perspective, where you're doing and looking at all these different patterns and cycles in the atmosphere from here to there, what are your thoughts on forecasting in terms of the future with AI?
So again, the AI, as you understand, right, it has to learn on something, right? So it has to have data to learn from to then predict something or do something, right? So the neat thing about us is our process is proprietary. Nobody knows how well what we do. It's not physics. Now, where AI has learned, it has learned on the big NOAA, GFS model and the European model, right? These governmental models that you guys are getting in-house to make your forecast out 14 days, right? They're able to train off of the initialization of those big multi-million, billion-dollar models with thousands of employees to control those models and on Cray computers that cost billions of dollars to run. So they're able to take that initialization, the 0 hour, and then model it going forward in seconds on a laptop. Right? They don't need the big Cray. They need the big Cray up until that point. But from there forward, on a computer, laptop, they can run the entire process that the Crays are currently doing. So their cost savings for the government eventually will be ginormous because they don't need to run that Cray for another 3 hours to do all this forecasting. So, it's got a ways to go. It did a great job on this hurricane, right? I mean, hurricane, if you look at it, maybe 10 days ago, the AI model did very well at saying it was going to hit Houma, Louisiana, and it hit Houma, Louisiana. Now, that's not always the case. I can point to a couple of hurricanes last year that said it was to destroy the Northeast, and it was off by about 400 miles. Well, that's important in hurricane forecasting. So it's got a ways to go, but it's certainly,
we're at the
going
cusp.
to make our lives potentially easier.
Right, we're at the start. And you and I were talking about that with some of the stuff you guys run. You guys use the cloud to process because, like you just brought up, there is a lot of processing power needed to make these models. Part of the reason why those future radars you mentioned, like the American, which is that GFS, the European future radar, only come out about 4 times a day. So it's kind of cool to hear your perspective saying, AI, hey, we're going to get it sooner because you're going to be able to kind of crunch a lot sooner. You're not going to need as much of that computing power. And I love kind of looking into the future. Hey, let's talk a little bit more about the future. Tell me more about how a volcano has been affecting global weather.
Yeah, so the one thing in our process that can hurt our forecasting year ahead, and fortunately only happens once every 20, 30 years, and is a volcano, right? So you have land-based volcanoes that blow up, like Mount Pinatubo in Philippines in 1992, I believe. That was a land-based that threw up what? Sulfur dioxide. Sulfur dioxide pumped 100,000 feet in the air, went around the entire world with all the Hadley cell circulation, right? That created global cooling for about 3 years. SO2 blocks sunlight, so the Earth got colder during that.
And by the way, this has happened before. Think about, I think it's like the year without a summer, 1815, there was a huge volcano, released a lot of ash, it stayed in the upper atmosphere, and it ended up blocking out sunlight. And Pennsylvania got snow in June in the 1815, somewhere around there in that decade. So this is not uncommon. So all right, so then you make it cooler. Then they give off a lot of moisture because the volcanoes, they're kind of where all the moisture, it's coming out of the ground and going up in the air, and then all that moisture that's staying up in the air, it stays there for a while until eventually it comes out, right?
So Tonga in January of 2022 was an oceanic southern hemispheric volcano. It was in the ocean. The ocean blew up. If you saw, it was the most epic thing, right? We caught that on satellite. I mean, the pulse that went around the world, it was epic, right? And we caught it, and that was ocean. So you pumped up about 4 trillion gallons up into the upper atmosphere. It took a while, the southern hemisphere, but it took a while to get around the whole northern hemisphere, the whole globe. But you put about 10% more water vapor in the atmosphere, right? The atmosphere doesn't want that much more water up there. Now, it does 2 things. One, that's a greenhouse gas. Water vapor is the opposite of SO2. It blocks the Earth radiation, right? So the Earth got hotter in part because of that volcano. Everyone overlooked it, but you can't put 10% more moisture in the atmosphere, trillions and trillions and trillions of gallons, and not have an influence. It did. And then if you look at what happened globally, and we track indexes all over the world, Russia or the French Olympics, right? The rivers were flooded because the previous months were the wettest in 40 years. Mississippi River, right? It was the wettest since 1993, 31 years. So happening in the Houston or Louisiana, they've been the wettest since Harvey in 2017, the second wettest in history. You're seeing a lot of the world. Like we work with some insurance clients, and convective thunderstorms and flooding are the catastrophic thing happening almost on a global scale. So we can point to Tonga as the cause for that. The big thing for you and I as scientists, right, is to figure out how long does that stay up in the atmosphere. We're in year 3. Right. Is it going to precipitate? Is it done? We don't know. We don't know yet, right? So
that's the hard part. And that gives more opportunities for research. But back to your point, insurance companies look at that. There's more this extreme weather that ups the prices. Part of the reason why our insurance prices went up a couple of years ago, they realized we're getting more extreme weather, but we're not kind of factoring in how much that's costing us. Captain Bill Kirk, I got to tell you, thank you so much for your time. Thanks for educating me. I always learn anytime I see you, and I appreciate you sharing that with all of us right here in Fox Weather Philly.
Good to see you.
All right, we'll be back here in 2 minutes talking about how we have potential to see northern lights coming up later tonight. So we'll see you right back here in just a few to chat about that.